Welcome to the CS312 Fall 2019 Exam 1 walkthrough. This will just go over part 1 of the exam, which is over expression evaluation. So let's begin with our first question. Number 1, 6 times 2 minus 3 times parentheses 5 minus 10. What we should do is just go through this expression in order of left and right, and identify what the first operation that has the highest precedence is, right? So the first thing that we have is the parentheses. And within the parentheses, the thing with the highest precedence, which is the only thing in this case, is just the subtraction sign. And so within the parentheses, we get -5. So we can rewrite this expression now as 6 times 2 minus 3 times -5. Now we'll just go from left to right and see what the next highest precedent operator is. That looks to be the multiplication sign, right? The multiplication operator. In this case, we have two of them. We have 6 times 2 and -3 times -5. So this will be 6 times 2 is 12, and -3 times -5 is 15. And so since this is a negative, we just turn this into a positive, and we add them together, we get 27. Okay, number 2. This is 10 divided by 4 times 20 divided by 15. So keep in mind here that multiplication and division are on the same level of precedence, so we just evaluate them at the same level. So that means we have to go left to right to break the tie. Since we're dealing only with integers here, we're going to be doing integer division whenever we see the division sign. So the first thing we want to do is 10 divided by 4, which is 2. Then we have 2 times 20 divided by 15. Next, 2 times 20 is 40. So we get 40 divided by 15. And finally, 40 divided by 15 is 2. Number 3, we have 0.5 plus 5 divided by 2 times 2.5. So in this case, we see that we're mixing our doubles with our integers. But we need to keep in mind that until we hit doubles, we have to do integer math first if it is of higher precedence. So the thing with highest precedence in this case is going to be multiplication and division. And since we go left to right to break their ties, then we first have to divide. So we first take 5 divided by 2, which is 2, not 2.5, because of integer division. So we get 0.5 plus 2 times 2.5. Next, we multiply 2 by 2.5, and we get 5. So we get 0.5 plus 5.0, because we're multiplying an integer by a double, and the result is going to be a double. Then we just add these up together, and we get 5.5. Number 4. We have 100 divided by parentheses 20 times 20 times 703.0. Well, this is going to look a little complicated, but thankfully, if you know what you're doing, it's not that hard. You don't have to actually multiply by 703, that's just to scare you. So I'm giving away a little bit too much hint here. But anyway, let me get down to it. So over here, we have 20 times 20, right? And this is within our parentheses, so we evaluate this first. So we get 100 divided by 400 times 703.0. Now, since we have division first, and division and multiplication are on the same level of precedence, we go left to right, and division's on the left. So 100 divided by 400, we're dividing an integer by an integer, so we're doing integer division. And that's just 0, because the remainder is 100, but just dividing it, you get 0. So you get 0 times 703.0. Now, you might be tempted to just say, oh, anything times 0 is 0, but remember, you need to keep in mind the data types. So on the left we have an integer, and on the right we have a double. So the result's going to be 0.0, which is a double. Number 5. We have 50 mod 15 plus 33 mod parentheses 10 times 6. Okay. Now, we first do the parentheses. 10 times 6 is 60. So we get 50 mod 15 plus 33 mod 60. Okay? And now we just go left to right. So 50 mod 15, 15, 30, 45, 60. We just end up with 5. Meanwhile, 33 mod 60, it's just 33. So the result we get is 38. Number 6. 5.125 mod 0.25. Now this is a little tricky because can we modulus doubles? Then I guess yes we can. So what you'll do is you'll simply divide 5.125 by 0.25 and see what that result is. But just treat it like it's the result's going to just be the integer, right? So if you do this, you'll find 5.125 divided by 0.25 equals to be about 20 point something, right? Then 20 divided by 4 will get you 5, right? So it's 20 point something, something, something. So what you could do is just take 20, let's just say 20.0, right? Multiply by 0.25, and you get 5.0, okay? You take 5.125, subtract 5 from it, and you get 0.125, right? And so the key here is just that this decimal point, right? That's really what we're looking for. It's well, not really the decimal point, but just the remainder, right? So even if we divide, just keep in mind whenever we're doing the modulo operator, we're really just looking for the result of the remainder, right? So the result of this operation is 5.125 modulus 0.25. We're just looking for the remainder, okay? And this is how you calculate it easily. So the answer here is 0.125. Okay. Number 7, we have 10 times negative 5 plus 100 plus GDC. Okay. So we'll just go left to right in terms of highest precedence. So the first thing is negative 50, right? Because 10 times negative 5 is negative 50. Then we add 100 and then GDC. Now we just have the plus operator, so we just go left to right. Before we hit a string, we still do have some integers to add up, so we'll add them up, and we get 50 plus GDC. And now that we've hit a string, we have to convert everything into a string, concatenate. And so this is equal to 50 GDC. Okay, 8 minus 2 plus quotes 8 minus 2, no spaces, plus 8 times 2 plus 8. Okay, this is a lot of 8s and 2s, but we can get through this. Okay, so the first thing is we just want to identify the operator of highest precedence, in which case here it is the multiplication operator. and that's between 8 and 2. So we can rewrite this as 8 minus 2 plus quotes 8 minus 2, no spaces, plus 16 plus 8. Now that everything is the same operator, we know we have to go left to right, okay? Well, as we can say it, it's more like 8 minus 2. The minus sign here is on the same level as plus and minus. So what we can really do here is just treat it as a plus and minus. Before we hit any string, we just treat all the math operators as math operators. So here we do 8 minus 2 is 6, plus 8 minus 2 plus 16 plus 8. So now that we've hit a math operator, now we have a string, we'll just concatenate it. So we do 6, 8 minus 2. This is string plus 16 plus 8. And so what we can do here is just add them up. 6, 8 minus 2. And we just concatenate these numbers instead of adding them up because it is preceded by a string. 16, 8. This is our final answer. Number 9. We have quotes, double quotes, 2 sets of them, plus 8 mod 16 times 10 plus 2. Okay. So we will look at what is first here, which is the modulus operator, right? And this holds the highest precedence in this case. So we just do 8 mod 16, and that's 8. So quotes plus 8 times 10 plus 2. We first evaluate the multiplication sign, so we have double quotes 80 plus 2. And because now we just have plus signs and they're preceded by quotes, we concatenate this. So our final answer is 8, 0, 2, and this is a complete string. Okay. Number 10, we have int negative 1.9 times 2. What we'll just do here is we work on the inside. We get int parentheses 19 times 2 is 38, so it's negative 3.8. Okay, and we just chop off the decimal point when we're converting to ints, so we get negative 3. 11, we have int 3.75 times 3 plus 13 mod 5. So we go left to right in order. Now, what has the highest precedence in this case? Actually, the casting operator, believe it or not, has the highest precedence. So what we'll do is we will first convert this, right? Since there are no parentheses here, this is clearly what this means. So we convert this to 3 times 3 plus 13 mod 5. And now we just go in order. 9 plus 13 mod 5 is 3. And your answer is 12. Number 12, we have double of 10 divided by 4 times 3. Now, careful. You're tempted to think that, oh, we're converting this to a double, so we should just treat the integer division as a double division, decimal division, regular division. Well, this is actually not true yet because we do the double conversion at the very end. So we still have to treat everything, all these operations inside here, as integer operations, and we still have to just put everything inside, treat them as integers until we convert them to doubles. So we do first, left to right, 10 divided by 4 is 2 times 3. Then we get 6. So we get for double 6. And finally, that would be 6.0. Number 13, we have quotes plus 3 times 4. And so, oops, excuse me, we have simply Java 12 because 3 times 4 is evaluated first. Number 14, math dot path. Two point zero, 3.0. And so we can see that this is simply just taking 2.0 raised to 3.0 power, and we all know that's 8. But because it's a double, it's 8.0. 15 is math.floor (100.5 divided by 30.5). Okay, and so we know that this is around 3 point something, right? I don't know what exactly it is. It's 3 point something, because I know 30.5 times 3 is roughly around 91.5, and 30.5 times 4 is about 122.0, so I know 100.5 is in between there, right? But it doesn't matter because floor just rounds down, so I know that the end result is going to just be, what, 3 point something round down? It's always going to be 3.0. And because we know that this is a decimal point, because we know that floor returns double, we know the result's at 3.0. And finally, 16. This one's a little hard, a little tricky. Actually, it's very tricky. So when I first saw this problem, I thought, how could you have math.random in here? Because wouldn't math.random make the problem, make this solution non-deterministic? aka wouldn't be a finite solution, it would be fixed at some certain number? Well, it all depends on how well you know how math.random works in Java, and of course your order of operations and precedence. So if you looked at this carefully, int math.random times 4 plus 2. Why don't we start with precedence first and then worry about what math.random does, okay? So the first thing what we'll do here is casting, because casting precedence comes first. We're going to have to cast math.random to an integer. So what exactly does math.random's values entail? Well, math.random, believe it or not, it doesn't actually take in any parameters. Instead, it just returns to you a double between 0 inclusive and 1 exclusive, and expects you to scale it up as needed for a random number in your range. So in this case, we're going to take our casting of math.random into account first. So the question is, what's behind math.random, right? So math.random is going to take a value between 0 inclusive and 1 exclusive. So we know that no matter what value math.random generates, it's still going to produce a number that's between 0 and 1. And because of that, when we convert it to an integer, it just becomes 0. So we take 0 times 4 plus 2, and that clearly gets us 2.